So hello guys, in today's video we are going to see how selection sort work and what is the code for it. So let's first understand how does it work and what is its algorithm. So it states that you have to take the minimum element and swap it. So get the minimum and you need to swap it. So what we have to do, get the first step is get the minimum and the second step is to swap it. Okay, so let's suppose we are given an array 13, 46, 24, 52, 20 and 9. So let's check it out how we can solve it. So this is an array of length 6. Length is 6, indexing 0, 1, 2, 3, 4, 5. So what we have to do, get the minimum element and swap it. So in the entire array, which one is the minimum element? So you start iterating from here, like you will put a variable over there and you will start looking. Mainly you have to take two pointers. This is called pointers, which means it will be pointing to this address or this memory location. So we have to take two pointers. Initial one is I and second one is j. Okay, so j will be traversing throughout the array and find and it will find the minimum element and then it will swap with I, because let's see how it works, then you will understand better that how it actually works. So initially I and j would be there. So now let's increment j and find which element is the minimum element, then 13 also, and in the entire array which one is the minimum element. So first j is at here 13. Okay, so let's take it here, j is equal to 13. So is 46 less than 13? No. Is 24 less than 13? No. Is 52 less than 13? No. Is 20 less than 13? No. Is 9 less than so let's j is iterating through this, and is 20 less than 30? No. Now j will move to this particular element and it will check, is j less than 13? Yes, this is we have found. So now update it and now move forward. So if we move forward, it will get out of the array. So when you got out of the array, then you will swap. In between, if you have found, let's suppose instead of 52 there is, let's suppose 10, so you don't have to stop at there, you need to traverse whole array, because maybe there is a minimum element then 10. So we need to traverse entire array so that you have to take the minimum in the entire array. So the one which we got is 9. So the first iteration we have done j0 to n minus 1 and I was there. So what we will swap, this particular j minus 1, because j was moved to forward. So j and ith position. So we will swap 9 and 13. Okay, so in the first iteration you have got this. So now sort it up or swap it. So 9 is there, then 46, 24, 52, 20 and 13. Since we don't have to do with other element, only we have to swap I and j. So this is the array that we have got after swapping. So I was there, so I is sorted, because see, we have found the minimum element, that is here I in itself. So initially I was at 0th position, now I will be at 1th position, so I will be there. So now let's traverse j to the entire array. Okay, so initially j is 46, okay, for this particular array. So now move forward, j moved here, it find 24. So 24 is less than 46, yes, then update. So this is 26. Now move forward. So we have swapped the 13 and the 9. So 9 is there and 13 is there. So we move to the second iteration, because initially I was there at the 0th position. In the second time I would be at 1th position. So I is there. Now let's start traversing j from this particular element to the last of element. You need to remember that j will only traverse from I to n minus 1, because since in the previous traversal you have sort 9, because what you have did in the entire row, that you have take the minimum element and put it into the front, because this was the only minimum from rest all. So this particular part is sorted right now. So now I is there and j is there. So now let's start traversing j in the entire array. So initially the minimum value is 46. Okay, so minimum value is 46. Move j forward. So j goes to second element. So is 24 less than 46? Yes, then update the minimum, that is 24. Now move j forward. J goes to here, this is 52. So is 52 less than 24? No. So move forward. So j goes to 20 and check, is 20 less than 24? Yes. Then you need to update the min element. So j is now cut it over there. So now let's move to the other element. So is 13 less than 20? Yes. So you updated the minimum element. So which is the minimum element that you have got? Is 13, right? So what now you will do is swap ith value and the minimum value that you have got in the array. So swap 46 and 13. So in the second step, what you will got? 9, 13, 24, 52, 20 and 46. So did you notice that this part of the array is now sorted, because 9 is the smallest in the entire array and 13 is the second smallest in the entire array. Now again start traversing. So I was at the 1th position. So after this traversal I would be at 2 positions. So I is now at there and j is also at there. So now the minimum value will be this. You will consider initially wherever is the jth element. So initially it is 24. So you have to take 24. Now move forward in the array and check whichever is the minimum. So j goes to here, 52 less than 24. No. J goes there, finds that 20 is less than 24. So updates it. Goes forward, checks 46 is not less than 20. So what is the minimum element right now? 20. So 20 will be swapped with I. So this particular element will be swapped by this minimum element. So in the what we will got if we swap it? 13, 20, 52, then 24, then 46. This is the array that we have got right now. So now in the third iteration, where I would be at this position and j also will be at this position. So now let's check the minimum. So initially whichever is the element is at jth position, you will consider that. So it is 52. Now move j forward to this particular element. So is 24 less than 52? Yes. So update it. So it is 24. Now move j forward. So j goes to this particular element and checks 46 is less than 24? No. So it will end up. Now checks 24 is the minimum element and ith is the 52 element. So it is possible to swap. So we need to swap this element and this element, because this is the minimum and this is the ith element. So what we have got? 9, 13, 20, 24, 52, 46. Okay. Now let's see. So now I would be at which position? 4th. So 0, 1, 2, 3, 4. So I would be at there. Now let's check the minimum element. Let's write it here. It is messed up here. So I and j are both at now same position. Now move j forward. So initially the minimum value is 52. Now check, go forward and check, is 46 less than 52? Yes. So 46 is less than 52. So we need to swap this particular element and this particular element. So let's swap it. So in the next iteration, what we will got is 9, 13, 20, 24, 46, and since it is swapped, so 52 will be. So this is our final array, and what I am telling you is that if you need to move further I, then there is no need to move further I and j, because it is the last element. And what you will find is smaller than 52, because the array ends at there. So you will never look for the last element. So we only need to consider this till this particular element, because if there is a single element in an array, let's suppose this is 4. So how you will sort, it is already sorted. So if you look like this, so it is only 52 left over there. So what will you sort? Because it is a single element, so we don't have to consider this particular element, last element. So I will only go to 0 to n minus 2 element. Since the length was 6, so last element is 5 and this particular element is 4. So the formula for this is n minus 1, this is n minus 2. So you can look over the entire explanation that I was going to 0 to like wherever it was sequentially going. So there is no need to go I to this place. You can take it also, but there is like no benefit of it. So we will only consider this to n minus 2th element. So this is our final array. Now let's jump into the code and see how exactly it works. So if we talk about the logic, so what was the logic? Initially there was 2 pointers. So write it I and j. We were doing like initially there is a for loop which goes from I 0 to wherever till where I have told you till n minus 2. So I will go from 0 to n minus 2, and inside this the for loop will go till which particular element? N minus 1, because j has to check for every element. So j needs to go to every element. So j will go to 0 to n minus 1, because this last element is n minus 2 and last second is the n minus 2th element. So I will only go to this particular element and j will go to the last element. Now what was the main logic? We were taking an min variable which was storing the value, or you can say which was valuing the index. Since I was telling you by showing the element value, because you need to understand first this. So actually in the programming there is you need to store the index number, because if you have stored the index number then you will sort it, right? If you have not stored the number, then how will you sort it? So you need to take, instead of this value, you will store the index number. So what was you will store the index number. For only for explaining you, I have shown you like this is a particular element, but in actual coding we need to take the index number. So inside this, or you can say, because minimum was consistent and holding value till the entire j was moving. So we need to declare it before the j like traverses. So initially the min would be the same ith element, because remember when we were traversing the element which was at ith or jth, initially the both were same. So initially we need to take the minimum as I, and then now j goes to, instead of 0, j goes to I to n minus 1. So j goes to I to n minus 1 element. So initially minimum would be I, and in each particular element what we were checking, that if the ARR of j is less than ARR of minimum, which means is the current element less than the minimum element? Is the current element less than the minimum element? So if yes, then what you will need to do? You will update the min index to be j. So this is the entire logic, and you can close the both loop, because this is the only thing that you have to take in consider, and these two are the main condition, that I will be I traverses from 0 to n minus 2 and j I to n minus 1, and the main logic is this. So after each particular traversal, what you will need to do is like that. I have closed it here, but actually it will now swap this particular min index, ARR min, and what it will swap? The ARR of ith, right? And then for because I was telling you that I will be fixed at any particular position, I would be fixed at any particular position, and j would be moving, and at the last whichever is the minimum, it will swap it with this. So same in the code you can see that the j goes from I to n minus 1, and this the main logic of this is to find the which is the minimum element after the ith element. So it will find and swap it with it, and after that the main loop also will end up, and if you need to return it, you can return over there, or whatever you would need to print or something, you can print over there. So let's go into the code and see how actually we can code it. So now let's start coding how it actually works. So for the selection sort, we have taken the same array, and now let's code it up. So what is the first thing that we need to take? So first is the initial array that will go from I from 0 to which particular index, which is first we need to find the length of the array. So int n is equal to arr dot length. So it will give you the length of the array. So it will be less than n, but actually till where we need to travel the I, we need to take to the last second element. To go till the last second element, we have taken less than n minus 1. So it will go to this particular index and I plus plus. And inside this, we need to take another array, that is int j is equal to, and since j will go from I to j less than n minus 1, j would go to the last element. So j don't need to go to n and minus 2, j will go to till the last element. So these two are the main loop, and what exactly we need to do, if arr of j is less than arr min, then we need to swap the two value. So we need to store the minimum. So here we will declare a variable that is minimum, which will store the minimum index of that particular iteration. So if the arrj is less than the minimum, so it will we will update the minimum to be minimum is equal to j, and after this particular loop will execute, we will simply swap the two values. So we have to take a temp variable by which we can store the first which is arr of I, then we will put arr of I is equal to arr of min, then in the arr of min would be temp. So this will ensure that you have sorted it up or not. So we have taken this array and we have sorted it up. This is the main code. And at the end, what you need to do is you can print it out to check whether it is sorted or not. So int x colon in the arr, and now let's print it. So print x. So now let's run it up and verify it is correctly working or not. So let's see the result. So it is 9, 13, 20, 24, 46, 52. So it is in the sorted fashion. So if we will remove println, so it will be on the same line. So let's do it. So now you can see it is sorted. And if we want to check whether it sorts or not, so what we will do is print the same thing before, like before sorting and after sorting. So we will says original, and here we would say after sorting. After sorting. So now let's run it up and see exactly how it sorts. Okay, no issue. So just put an empty sort over there and it will keep it. Yeah, so original is 13, 46, 24, 52, 29, and after sorting the 9 goes to the front, 20 goes to this particular index, and all the elements are sorted. So thanks for watching this video. If you have understood some concept, so make sure to hit like and subscribe. So thank you for watching.